When people hear Claude, Mythos-style, or other upcoming frontier models, they imagine a movie villain. The more realistic threat is quieter. These systems are getting better at reading code, tracing architecture, correlating logs, and turning scattered facts into a vulnerability hypothesis. They are not autonomous elite hackers today. But if they keep shrinking the time needed to understand a target, write harnesses, and test exploit paths, then software teams face a real security shift. Attackers do not need magic, they just need speed. A deep cybersecurity specialist may know one bug class better than anyone, but many real incidents are not one-domain problems. They sit between application code, cloud permissions, CI pipelines, package behavior auth rules, and developer assumptions. A broad model carries working knowledge across all of those layers at once. That cross-domain breadth lets it connect a permissive IAM role to a debug endpoint or an unsafe parser to an internal admin path. Bugs often hide between domains, and that is exactly where generalist models can move surprisingly fast. Imagine a model reviewing a pull request, API schema, Terraform diff, and error logs in the same session. It notices a temporary admin flag, an overbroad service role, a deserialization helper, and docs that reveal how support tokens are minted. None of those clues screams critical on its own. Together, they suggest a chain: leak a token, reach a privileged path, then turn a minor code bug into real access. This is why LLM risk is partly a software engineering problem, not just a pure cybersecurity problem. This is not just hype. CyberSec Eval 2 showed that model behavior on cyber tasks changes meaningfully with capability and setup. Project Naptime argued that better agent scaffolding can reveal much stronger offensive performance than naive one-shot testing. Then Big Sleep showed a frontier model-assisted workflow helping find a real SQ-Lite vulnerability before release. At the same time, OpenAI's GPT-4o system card still rated current cyber risk below its medium threshold. The evidence points to an uncomfortable middle ground, not full autonomy, but clearly enough capability to matter. Current models still hallucinate, miss target-specific context, and often fail without tools, retries, or human steering. They are inconsistent on novel environments, and strong exploit development still depends on careful experimentation. That caveat matters because hype hides the real risk. The dangerous scenario is not a single prompt producing a zero-day from thin air. The dangerous scenario is a model helping a mid-skill operator do stronger variant analysis, faster patch diffing, faster triage, and faster exploit adaptation. Most teams do not run clean, fully understood systems. They run sprawling repos, rushed deployments, stale dependencies, secrets in the wrong places, and CI bots with more access than they should have. Add internal copilots, repo agents, and automation that can read tickets, code, docs, and logs, and now the model gets the exact context attackers want. If your engineering environment is messy, a capable model does not create the mess. It turns that mess into a searchable map of your weakest paths. The defense is better engineering discipline and tighter AI boundaries. Treat model outputs as untrusted, especially around auth, crypto, deserialization, interpreters, secrets, infrastructure, and memory-unsafe code. Give internal agents least privilege access, short-lived credentials, and isolated execution. Require deterministic checks before code, shell commands, or deployments can land. Invest in fuzzing, sanitizers, dependency hygiene, fast patch rollout, and segmented sensitive repos. And red team your own agent workflows for prompt injection, secret leakage, and tool abuse before an attacker does it for you. So if Claude, Mythos-style, or other upcoming frontier models keep improving, the most likely software threat is not instant superintelligence. It is accelerated cross-domain reasoning applied to fragile systems. Models that know a little cybersecurity, a lot of software engineering, and enough tooling to test hypotheses can find the cracks between teams faster than many specialists expect. The safest assumption is simple: model capability will improve faster than most organizations clean up their software. Plan for that gap now.